Red Bull's 2026 engine just triggered a full-blown panic inside the Formula 1 paddock, and it's not even race-ready yet. Early testing shows it's already producing hybrid torque delivery far beyond what the regulations expected, and it's not overheating, not glitching, and not slowing down. It's Red Bull and Ford's first fully in-house power unit, and insiders are calling it the most advanced integration of electric and combustion tech the sport has ever seen. Subscribe right now, because if this monster hits the track like it's hitting the dyno, Red Bull may have just crushed the 2026 season before anyone else even fired up their car. Red Bull is no longer just the team with the fastest aero concept, they are now officially a full-scale engine manufacturer. And with the 2026 regulations about to upend everything we know about power unit philosophy, Red Bull's early performance is turning heads for all the right and terrifying reasons. After years of relying on Honda, they've teamed up with Ford to build their first in-house power unit, and what's coming out of the dyno room is already sending a warning to every other technical director on the grid. For context, 2026 introduces a completely new power balance. 50% of total energy must come from electric deployment, a massive increase compared to current levels. That means teams can no longer rely on combustion engines to mask hybrid weaknesses. The electric side must be powerful, efficient, and recover energy under braking like never before. According to sources inside Milton Keynes, Red Bull's current hybrid deployment system isn't just passing the test, it's leading it, generating high-density output with thermal control few believed was even possible this early in development. What's especially alarming to rivals is the rate of progress. While legacy manufacturers like Mercedes and Ferrari are still focused on component validation, Red Bull has already completed multiple full-system integration phases. They're not just running theoretical simulations, they're running real-world stress tests with live telemetry feedback. That means their system is already learning under race-like conditions, gaining a head start on reliability, mapping, and power curve optimization that no spreadsheet can simulate. Underpinning this early dominance is Ford's high-efficiency electric platform, which Red Bull has adapted with shocking precision. The battery cells are being managed with zonal thermal balancing, allowing for real-time heat diffusion across different packs depending on demand. In basic terms, the battery doesn't just store and release power, it thinks. It manages its own thermal environment so that electric deployment remains stable even under high-speed load shifts and variable track temperatures. The combustion side of the engine is no slouch either. Red Bull's ICE layout has been designed for low mass and high energy recovery. Unlike traditional V6 units that prioritize peak output, Red Bull's version sacrifices nothing on torque while integrating seamlessly with the ERSH and MGUK systems. Sources close to the project say torque distribution is already more linear and reliable than any engine they've previously run, a crucial factor in tire preservation and corner exit consistency, two areas where Max Verstappen has already built his advantage. This integration is what makes the package so terrifying. Instead of managing separate combustion and electric systems, Red Bull's unit behaves like a single energy organism. Power flow, heat dissipation, throttle response, and charge cycles all operate under one master control algorithm, dynamically adjusting based on driver inputs and track condition predictions. It's not just smart, it's predictive. That kind of system development is usually reserved for top-tier aerospace simulation environments, not Formula 1 garages. And now, the question across the grid is no longer, will Red Bull be ready? It's, how far ahead are they already? In a sport where milliseconds define legacy, the advantage gained during development rarely shows up in headlines until it shows up on track. And if this trend continues, Red Bull's new engine won't just be fast. It could be unstoppable. Inside Red Bull powertrains, engineers are running full hybrid control tests that go beyond standard FIA validation. The team has built a simulation rig that maps not just engine output, but how the power unit behaves under real aerodynamic load. That includes chassis flex, lateral g-forces, and downforce changes across an entire lap. By syncing the powertrain with these variables, Red Bull is able to fine-tune hybrid boost to match both grip and aero behavior, giving their drivers peak torque exactly when the car can handle it best. One of the least discussed breakthroughs is the use of real-time energy partitioning, where the engine's control unit decides in milliseconds how to split incoming recovered energy between immediate deployment or short-term storage. This system isn't binary. It's gradient-based. Meaning, the car calculates how much energy is needed for the next 5 corners and distributes accordingly. For example, in a sector like Suzuka's S-curves, the system balances grip loss, tire load, and throttle modulation to avoid wasting electrical power where it won't yield lap time. Another critical area of performance comes from dynamic torque blending. Red Bull has managed to eliminate the dead zone between combustion power drop-off and hybrid kick-in. This is especially valuable in high-traction zones like the exit of Turn 3 at Barcelona or the final sector in Singapore. Most hybrid systems still create a delay at torque cliff where drivers feel a slight hesitation. But Red Bull's unit delivers a seamless torque band across the full throttle range. This not only makes the car more drivable, but also reduces rear tire overheating and traction control interference. The 2026 engine also includes a vibration damping system in the MGUK housing, built from a composite alloy using Ford's proprietary design. This material absorbs microharmonics from the crankshaft and inverter, reducing internal stress loads across the hybrid recovery unit. It means less mechanical loss, more efficient energy conversion, and greater long-term durability, all crucial under the new component lifespan limits imposed by the FIA. Simply put, Red Bull isn't just going faster. They're wearing out less doing it. On the electrical side, the inverter architecture has been reshaped entirely. Instead of placing it alongside the battery, Red Bull's layout stacks the inverter vertically behind the driver's survival cell, reducing wiring length and improving energy transfer time. In terms of performance, this means lower resistance, faster cycling, and cooler operation. It's a layout that could save milliseconds per lap, but more importantly, gives them more flexibility in energy timing during aggressive corner sequences. Perhaps the most forward-thinking innovation is the adaptive throttle prediction algorithm. This system uses driver behavior, steering input angle, and brake modulation to anticipate throttle applications before the pedal is even pressed. The idea is simple: beat the driver to the throttle. By pre-spooling torque through the MGUK based on projected corner exit behavior, Red Bull's engine can deliver instant electric torque with no lag. That responsiveness makes the car feel more connected, and according to early test feedback, offers a psychological edge in close combat driving. Lastly, while most of the grid is still struggling with heat soak and ERS fade, Red Bull is reportedly trialing a closed-loop energy retention system. Instead of dumping excess thermal energy into the atmosphere, it uses controlled cooling cycles to convert heat into electrical support for short bursts. It's not KERS. It's not passive ERS. It's a hybrid support phase built entirely into their own strategy, and if legal under the technical directives, it could become a hidden weapon available only to them. Red Bull's 2026 power unit doesn't just push boundaries, it redefines the engineering relationship between hardware and software. The engine and hybrid systems were developed simultaneously with a full digital twin, updated daily with live bench data. This means every physical change, whether a bolt, mount, or control protocol, is instantly reflected in the simulation. That gives engineers real-time clarity on how the car will behave weeks before components are even track tested. It's not just innovation, it's predictive development with zero wasted cycles. One of the most striking architectural shifts is Red Bull's centralized energy command system, which unifies all electrical subsystems under a single control layer. Most power units still rely on tiered communication protocols between the battery, inverter, and MGU units. Red Bull's solution merges those functions under one high-speed data loop, cutting signal latency and increasing responsiveness. That means electric boost can be activated with greater precision and deactivated instantly to protect tires, manage traction, or shift energy toward harvesting. Another leap forward is the re-engineered engine block, designed not just for combustion but for thermal routing. Red Bull's engineers used advanced computational fluid dynamics to create internal coolant veins that behave like arteries, adjusting pressure and flow based on external heat conditions. This allows the engine to breathe under strain and reroute coolant to priority areas in real time. It's a living system, regulating its own temperature zones like a biological organism, something not seen before in F1 engine design. Suspension and engine design are no longer separate silos. Red Bull's gearbox and rear suspension mounts are now torque cooperative with the power unit, meaning rotational forces from the ICE are used to stabilize rear load under acceleration. By aligning the engine's crank harmonics with suspension travel points, Red Bull reduces squat and rebound delay. This keeps the rear tires flatter under throttle and improves straight-line acceleration without increasing downforce, a critical benefit under the drag-limited 2026 aero rules. The integration between driver and power unit has also taken a major leap. Red Bull's new steering and power delivery interface gives the driver control over how electric torque is applied during different track segments. Think of it as sector-specific torque mapping rather than a single engine mode. The system reads the upcoming corner profile and throttle trace, then selects the most efficient delivery pattern. It's no longer about brute force. It's about deploying power exactly where it buys lap time and nowhere else. From a packaging standpoint, Red Bull's engineers have managed to shrink the entire rear-end footprint by over 10% compared to their 2025 car. This has been achieved by integrating heat exchangers into the structural carbon tub and relocating auxiliary systems closer to the centerline. The result is more efficient weight distribution, a tighter floor, and enhanced underbody airflow, which not only boosts downforce but significantly reduces rear turbulence. It's how Red Bull is gaining aerodynamic edge without touching the outer surfaces. Lastly, and perhaps most ominously for the competition, Red Bull has started to feed this entire power unit system into its next-gen AI-powered simulator suite. The simulator doesn't just replicate track conditions, it uses machine learning to forecast tire degradation, energy strategy, weather shifts, and even opponent behavior. In short, they're not just building a fast car. They're training it to adapt before the race even begins. And when machine learning meets Max Verstappen's instincts, it becomes clear why the paddock is already rattled and why 2026 might be over before it begins.